Okay, we're going to have a look at the next little section of work on solving simultaneous equations. But before we do so, I'd just like to do one more example of solving quadratic inequalities. I've left some prep questions on that, and I'm also a little concerned that that we didn't get enough practice in class on this. So, and I also haven't put a YouTube together on it. So, hopefully, I'll do one example here, and maybe that will help do some work on those questions tonight. Not a straightforward concept solving quadratic inequalities. So let's look at an example. So the example here I'm going to look at is solve x squared minus 5x plus 6 is greater than 0. Okay, now in order to solve this, we need to factorise, and I've made one that's quite nice. Quite easy to factorise here, x minus 3x. Hopefully you'll agree that they are the factors of that quadratic, and that when we set up our little sign diagram, we are going to split it at 2 and at 3, given that they are the values of x that make, right, this is our x number line, they're the values of x that make this quadratic equal to 0. We want to find out whether it's greater than 0. Okay, so what we've done is we've factorised so we can see those numbers. That's the reason we've done that, so we can see the 2, we can see the 3, and then we put them down. So what number should we test here? I reckon we should test 0. So let's test 0 here. That's a test value. I'm going to test, well, I'm going to test 2.5 here. That's a test value. And I'll test 4 here. Just writing tests so we know that the red numbers are the ones that are splitting it up. So at 0, let's have a look at the value of this quadratic when x is 0. Well, I've got 0 minus 3, that's negative, 0 minus 2, that's negative. That's negative times a negative, so that's a negative times a negative, which results in a positive. So this is a positive zone. Get out my big orange pen and put in a big positive. Okay. Let's now check. Let's go and test 2.5. 2.5 minus 3, that's negative. 2.5 minus 2, that's positive. A negative times a positive, well, that's a negative. So that is a negative zone there. Okay, what do we want? We want a greater than zone. So right, we need to check the end. We're anticipating that it's going to be positive. 4 minus 3, put 4 in there, 4 minus 3, that's positive, 4 minus 2, that's positive, so that's positive times a positive, that's a positive result, and we've got a positive zone here. So the zones that work for us, greater than 0, are here, and here. So how do we write that? As two separate inequalities, x is less than 2, or x is greater than 3. Okay, and remember what we did how that slotted into our work on discriminants is that when we find a discriminant in terms of m or p or whatever it is, and we need to solve a quadratic inequality, that this is the work we need to do. Okay, moving on to the next section then, and that is solving simultaneous equations, which is not new work for us, but what is new, where we've got one linear equation and one quadratic equation. Okay, so let's just check out what the story is with this. Remember, when we solve simultaneous equations, we are finding the point of intersection. So remember when we did linear equations, don't take these notes. We are finding the point of intersection when we solve two linear equations, and unless they're parallel, there's going to be some solutions. So that's fine for when they're linear. What happens when one is linear and one is quadratic? Well, we could have two solutions when we solve. What are some other scenarios? Well, could we have quadratic and a linear? No solutions. Yeah, we could have that. Could we have a quadratic and a linear where the line is a tangent to the quadratic and get one solution? Well, yes, we could. So this is 2 solutions, 1 solution, 0 solutions. So there are the possible outcomes when we solve simultaneous equations. When there's one linear, which is a line, one quadratic, parabola, we can have those scenarios. Let's have a look at an example, and we'll have a look at how we solve simultaneous equations, which is going to be our next section of work. So solve, this is the example. Solve the simultaneous equations, or perhaps we could just make a note up here with these diagrams that a quadratic maybe I should write that as a parabola. And a line can intersect in 0, 1 or 2 or at making some errors, at 0, 1 or 2 points. And we've had a look at the demonstration, 2 points, 1 point, 0 points. Right, so let's go back to the example. Solve the simultaneous equations y equals x squared, which is obviously a parabola, and y equals 3x plus 4, which is a linear equation. So we've got parabola here, and we've got a linear, or a line, linear, making lots of errors, a line there. Okay, so what are we expecting to find here? Well, y equals x squared. If we just maybe have a little look at the graphs, it might help with our understanding of this. Y equals x squared, that goes down here, doesn't it? It's a parabola through the origin, up it goes. Y equals 3x plus 4, and that goes through about here on the y-axis, and then it's got a gradient of 3, so it's through like this. It looks like, I reckon there's going to be a couple of points of intersection around about those places. It's a very badly drawn graph, it's not to scale, but let's have a look at how we solve it algebraically. Now the way to do these is to solve the two equations in a substitution way. So you can see that y equals x squared from that equation, from equation 1, and y equals 3x plus 4 in equation 2. So both what I've highlighted there, x squared and 3x plus 4, they're both equal to y. So they must be equal to each other. So what we say in this case, and the method that we use, is we find out from both equations, make y the subject, and whatever y equals, make them equal. So 3x plus 4 and x squared, we're just going to make them equal to each other. So down here a little way, 3x plus 4 equals x squared. And so therefore, if we take x squared and bring the 3x and the 4 over to the same side as the x squared, we're going to have a quadratic that looks like that. And I think this is a nice easy one. I think minus 4 and plus 1 will solve that for us. So we've got the points x equals 4 or x equals minus 1. Now they're going to be the x coordinates of my points of intersection. But in order to solve the simultaneous equation, we're going to need to find out what y is as well. Well, y is equal to x squared. We can put these values of x here, back into either of my starting equations. And let's put it into x squared, because that's easy. So when x equals 4, y is equal to 4 squared. And when x is minus 1, y is 1. So this is the point minus 1, 1. And this is the point 4, 16. They're my 2 points of intersection, and so the solution, they're my two solutions, x equals 4, y equals 16, or x equals minus 1, y equals 1. And that's the method for solving two equations simultaneously, where one is quadratic and one is a linear. And in this occasion, there are two solutions, but there could be one, there could be 0, and that will just depend on the nature of these equations. Alright, I'll see you in class tomorrow, and we'll do some more questions on this.